let's try a little warm up. This right here, I wasn't sure what to do, so oops. First I turn on my pen. I draw a little triangle, A, B, C, and label it 75 degrees, 82 degrees. C is across from C, which is 16. We don't know B and we don't know A. Looks like here I have angle, side, angle, which I know I can do the law of sines for. So let's just, first of all, we need angle C. So 180 minus 82 minus 75 gives me 23 degrees. So angle C is 23. Now we can set up our law of sines. So sine of 75 over A equals sine of 23 over 16. Go ahead and multiply. 16 times sine 75 divide by sine 23 gives me A of 39.6. And then sine of 82 over B is same thing. I could use the same setup. So 16 sine 82 divided by sine 23 gives me, oh, this is A, sorry, B of 40.6. Right, let's see what we have here. It looks like I have side angle, which is that bad word, so we know that we have to see if we have one triangle, two triangles, or no triangles. So I have an obtuse triangle. So if I check my chart, if B is greater than C, because B is the angle I have, so if B is greater than C, I have one triangle. So that's just checking that chart on page 587. So we can go ahead and solve this one. Since we know we only have one triangle, I can say that sine of 131 over 52 equals sine of C over 38. So 38 times sine of 131 divide by 52 is 0.55 equals sine C. So sine to the negative 1 of 0.55 equals angle C. Angle C is 33.5 degrees. So 180 minus 33.5 minus 131 equals 15.5 degrees, which is angle A. So I can do sine of 131 over 52 equals sine of 15.5 over side A. Do that math. 52 times sine of 15.5 divide by sine of 131. Side A is 18.4. So I've got all my pieces and parts. Yep, ABC, ABC. Okay, last one. Two sides of a triangular lot are 80 feet long, and the angle between those two sides is 110. So I have angle, side, angle, and we are obtuse. Let me check the chart on that page again. Back to page 586, and when I have angle, side, angle, I can just use the law of sines. So 110, 80, 80. We can call this, I don't know, A, angle B, side B, angle C, side C. So sine of C over 80 equals, ooh, we definitely don't know enough, but I do have two sides are the same, therefore their angles are the same, an isosceles triangle. We know that when two sides are the same, the legs, so I've got these two legs with the same measurement, therefore the angles at the base are the same. So if I do 180 minus 110, 70 degrees, divide by 2 is 35 apiece. Therefore, I don't have to do sine C. I've got sine of 35 over 80 equals sine of 110 over A. 80 times sine 110 divide by sine 35. A is 131 degrees. Oh, measurement, not degrees. 131 feet. I'm going to redraw this. I didn't really think much about the problem when I started. I just started crunching numbers. So 110, 80, 80, and 131 feet. Area is 1/2 base times height. I need to figure out my height. I know an isosceles triangle, the height cuts the base in half. So 131 divided by 2 is 65.5. So I can figure out the height of the triangle. A squared plus 65.5 squared equals 80 squared, Pythagorean theorem. 80 squared minus 65.5 squared is 2,109.8. Square root of that A is 45.9. That's my height. So now I can find the area of the triangle. Area is 1/2 times my base, which is the whole base, times the height, 45.9. My area is about 3,008 feet squared. Phew! All right, let's get into what we're actually doing today. We spent last lesson talking about the law of sines. Today we are talking about the law of cosines. Previously, for the law of sines, we did angle, angle, side, angle, and side, side, angle cases. Remember, these were the easy ones. This I had to analyze a little bit more. In this lesson, you'll use the law of cosines to solve triangles when two sides and the included angle are known, or when all three sides are known. So now we're doing side, angle, side, and side, side, side. So the law of cosine says if triangle ABC has sides length ABC as shown, then these work. Okay, A squared, so if I'm trying to find this one, it's B squared plus C squared minus 2BC cosine A. What I try to remember is, let's see if I can get a highlighter here, and maybe a light yellow. I'm trying to find A, the side A. Notice there's no side A here. I'm trying to find side A, so I use angle A. Makes sense? When I'm trying to find side B, there are no side B's here, but I do refer back to angle B. Side C, there are no side C's, but I can refer back to angle C. All right, that's how the law of cosines works. So let's try one. This is side, angle, side, side, angle, side. I'm going to try to find side B. So I can say b squared equals a squared plus c squared minus 2ac cosine b. Okay, those match. None of the b's are here. So b squared equals 11 squared plus 14 squared, 2 times 11 times 14 times cosine 34. I know that's a mess, but we have calculators. I'm typing everything in. Cosine 34. I have 11 squared plus 14 squared minus 2 times 11 times 14 times cosine 34. That gives me b squared is 61.7. Square to both sides. B equals 7.9. I have everything else. Now I have to find angle C and angle A. And funny thing, to find those we use the law of sines. Sine A over 11 equals sine 34 over 7.9. 11 times the sine of 34. Divide by 7.9. Sine A equals 0.78. So sine to the negative 1 of 0.78 equals 51.1 degrees. And now that I have angle A and angle B, I can find angle C. 180 minus 34 minus 51.1 is approximately 94.9 degrees. Check my answers. Yep, 7.9. Cool. Angle A is 51.6. They got 51.1. Angle C, 94. They got 4. I got 0.9. So we're good. We're pretty close. So we had to use the law of cosines and then go back to the law of sines. All right. Here I have side, side, side. So I don't have any angles here, but I can use the law of cosines to find an angle. So what I'm going to want to find is the angle opposite the longest side. So here I have my longest side. I want the angle opposite. Angle opposite the longest side. So that is angle B. So I'm going to use b squared equals a squared plus c squared minus 2ac cosine b. Because I'm going to try to find angle B. Let's go ahead and plug everything in. 27 squared, 12 squared, 20 squared, 12, 20, cosine B. Okay, let's start simplifying a little bit. 27 squared, 729, 144, that should be plus, sorry, messy. 20 squared, 2 times 12 times 20, cosine B. So go ahead and subtract 144, subtract 400, gets those out of the way. 729 minus 144 minus 400, 185 equals 480 cosine B. I just noticed a mistake. Negative 480 cosine B. So I'm going to divide by negative 480, divide by negative 480. I get negative 0.385 equals cosine B. So take the inverse, negative 0.385 equals B. So B equals 112.7 degrees. I need more paper. Right, so far we know that B is 112.7 degrees. Alright, now I can use the law of sine. The law of sines is so much easier, so if I can use it, I will. Sine A over 12 equals sine B over 27. So 12 times sine 112.7 divided by 27. Sine A is 0.41. Sine to the negative 1 of 0.41 equals A. So angle A is 24.2 degrees. 180 minus 24.2 degrees minus 112.7 degrees is going to give me angle C. (24.2), 112.7. C is 43.1 degrees. There's my point. And all the sides are found. Cool. Okay, example 3. Use the law of cosines in real life. Scientists can use a set of footprints to calculate an organism's step angle, which is a measure of walking efficiency. The closer the step angle is to 180, the more efficiently the organism walked. The diagram shows a set of footprints for a dinosaur. Find the step angle B. So it looks like I have side, angle, side. So I can use the law of cosines to find, it looks like I have side, 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 right? I have all the sides. I'm trying to find the angle. So I have side, side, side. So I'm going to use the law of cosine to find angle B. So I'm going to use the B squared. You can't see that. B squared equals A squared plus C squared minus 2AC cosine B to find cosine B. But I'm going to do that on the next page. Right. B squared. Nope. So I'm using this equation. I'll write it real quick. Now let's fill it in. B squared is 316 squared. A squared, it doesn't matter which one we use. So we'll say this is, oh, no it isn't. So this is C. This is A. Okay, sorry. 155. 197. 2. 155. 197 cosine B. So subtract. 3, 4, 5, 10 equals negative 61070. Divide both sides. Cosine negative 1 of negative 0.565 gives me B of 124.4 degrees. me go back and read the problem. Find the step angle B. So it looks like I did. I got 124.3 degrees. Cool. I just saw a mistake. This should be 316. Okay, I'm not going to recalculate it though. If you'd like to, my answer is 127.3 degrees. I'm off by a few degrees by making that mistake. I just copied it wrong. Guided practice. Go ahead and try these on your own. The first one looks like I have sorry, it phased out for a minute. I just don't know which one I have. So I've got A is 8, C is 10, and angle B is 48. So I have side angle side, so I can use the law of cosines for. So I'm going to go ahead and solve it really quick on my own, and you can solve it too and check your answer. I'll be right back. Push pause. All right, there is the first one. Solved triangle ABC. Now let's look at triangle 2. It looks like I have side, side, side. A, B, C. So crossed, I've got 14, 16, and 9. So we take the biggest angle, the biggest side, and solve for the angle associated with it. 9 squared, 14 squared, 2 times 9 times 14 times cosine of angle B. Okay, I'm going to push pause and finish. You try too. Okay, I have B is 85.2, A as 60.7, and C as 34.1. What if, in example 3, suppose that A is 193 centimeters, B is 335 centimeters, and C is 186 centimeters. Find the step angle B. All right, I'm going to do 335 squared equals 193 squared plus 186 squared minus 2 times A times C cosine B. Be right back. I have B equals 124.2 degrees. Let me check my answer. Yep, cool, good job. All right, there's one more thing to cover in this lesson. It's called Herons formula. The law of cosines can be used to establish the following formula for the area of a triangle. The formula is credited to the Greek mathematician Heron. He was alive about 100 AD. Heron's area formula. The area of a triangle with side lengths A, B, and C is area equals S times S minus A times S minus B times S minus C, where S is 1/2 A plus B plus C. The variable S is called the semi-perimeter or half perimeter of the triangle. Let's try one. So the intersection of 3 streets form a piece of land called a traffic triangle. Find the area of the traffic triangle shown. So first let's find the semi-perimeter. S equals 1/2 A plus B plus C. That gives me 380. Moving on, now we can use Heron's formula to find the area. Square root of S times S minus A times S minus B times S minus C. All right, let me crunch some numbers. Crunching all of that gives me an area of about 18,307 square yards. All right, try this one. Find the area. First you have to find S, and then using S, find the area. I'll be right back. So the area here is about 18.3 square units. Same thing here, you can go ahead and practice it. I've got area about 13.4 square units. It's a lot of these to practice. The area here is about 80.6 square units using Harrods method. Alright, if you need some more practice, here I have side angle side. I'll give you answers. If you like to practice them, you can check your answers. I've got B is about 38.2. A is about 39.7 degrees. And C is about 63.3 degrees. Here I have A is about 34.5 degrees. B is about 44.9 degrees. And C 100.6 degrees. Two people start walking straight paths. We're looking for, again, that angle. Actually, here we have a side. How far are they apart? Let's set this one up. Straight paths that make an angle of 112. I don't know. Let's do this one. After one person has walked 1.2 miles and the other has walked 1.8 miles, how far are they apart? So we're looking for that distance, so we can use the law of cosines to find it. Go ahead and try that, and you're going to get about 2.5 miles. And here it's Harrods area. We're going to get about 487 centimeters squared. Good work.